Hi, this is Sujit. I'm going to talk about diuretics and electrolytes today. But I suppose before we start, we need to understand how do diuretics act. All diuretics act by one single principle, and that's inhibiting the reabsorption of sodium in the tubular cells. At the level of glomeruli, with a GFR of 125 ml per minute, we make about 180 liters of urine, but we pass out only 1.5 to 2 liters of urine. So more than 99% of the water in the tubular lumen is reabsorbed. Now out of this 99% water, about 90 to 95% of the reabsorption is because water just passively follows the sodium. It's only when we go to the distal part in the collecting duct that antidiuretic hormone reabsorbs some water independent of sodium. But as I said, more than 90 to 95% of the total water is reabsorbed because it's just blindly following sodium, which means these lining cells are hungry for sodium and they're constantly chucking in sodium from the urinary lumen. Now what makes these cells hungry for sodium is on the basal side, and you remember we've got the interstitium and we've got the peritubular blood vessels here. On the basal side, all these cells have sodium, potassium, ATPase, which is constantly chucking out 3 sodium and pulling in 2 potassium. So net result, these cells are deficient in sodium and rich in potassium. And because they're deficient in sodium, they just keep reabsorbing sodium and the water just keeps following the sodium. So let's say I put someone on a loop diuretic which acts on the thick ascending limb of loop of Henle, or thiazide diuretic which acts on the distal convoluted tubule. So because I've stopped the reabsorption of sodium, and as sodium goes out it carries water with it, and hence the diuretic effect. But as this sodium rich water reaches the collecting duct, the cells sitting there say, okay, we are losing too much sodium and we must try to get some back. So they try to pull back some of the sodium. Remember, those cells are also hungry in sodium. But as they pull back sodium, the urinary lumen says, all right, you have taken away some of my positive charges. Can I please have something in return? So in return, a bit of potassium and a bit of hydrogen leaks out into the urinary lumen. So which means if I'm on loop diuretic and I'm on thiazide diuretic, I'm losing potassium and hydrogen in the urine, and hence I can be hypokalemic and alkalotic. But I think that's just half the answer. The other half of the answer is when you put someone on a diuretic, there will always be a mild intravascular volume depletion, which will lead to activation of renin, angiotensin, and aldosterone. And what does aldosterone do? So aldosterone in the distal part of the tubule, in the collecting duct, it basically pulls in sodium from the urinary lumen. And as it does that, it also helps to kick out potassium into the urinary lumen. But I think it's not a one-to-one thing. So aldosterone reabsorbs more sodium than it kicks out potassium. So the urinary lumen says, okay, you have taken away too many positive charges in sodium, but you have not given me enough positive charges in potassium. And then as an indirect effect, through the intercalated cells, a bit of hydrogen also leaks out into the urinary lumen. So which means if I'm on loop diuretic or on thiazide diuretic, because of intravascular volume depletion, my renin, angiotensin, aldosterone is activated, and as my aldosterone is high, I'm losing potassium and I'm losing hydrogen. So again, that adds on to basically the picture of hypokalemia and metabolic alkalosis, which we see with these two diuretics. The other group of diuretic, the aldosterone antagonist, things like spironolactone, basically they prevent the reabsorption of sodium in the principal cells where aldosterone normally acts. But remember, the reabsorption of sodium here under the influence of aldosterone is linked to the excretion of potassium and indirectly excretion of hydrogen. So if I'm on aldosterone antagonist, I will not be able to excrete hydrogen, I will not be able to excrete potassium. So this means I'm hyperkalemic and acidotic. So that's the difference. People on loop diuretics and thiazide diuretics, if you start to look at their bloods carefully, especially people who are on big doses for some time, they border on the hypokalemic and the alkalotic side of things, where people who are on spironolactone or amiloride or trimethoprim, they tend to be hyperkalemic and acidotic. Hope that helps. Thank you.